we're going to talk tonight about quantum computing, and I know that some of you have some experience, some of you may not. We're going to talk for about 15 minutes on the topic and try to leave, that room they talked about for the Q&A and some extra. And we're going to show you a bunch of stuff that nobody has, well, very few people have seen so far. And that is, in addition to telling you why this is important, why I'm excited about it, where it's going, I also want to tell you where you can find resources that you can tonight get started with working with quantum computing, learning about it, playing around with it, getting networked into the community, et cetera, et cetera. So the way I wanted to approach this is everybody's heard of quantum computing. A lot of people don't quite understand what the big deal is. And I kind of wanted to approach it from why don't we talk about the power of a quantum computer? And we'll talk about the different kinds, we'll talk about the different techniques, I'll cover all of that. But kind of talk about some of the algorithmic stuff as well. Like Jay said, some of this will be very high level, some of it will be a little bit more detailed, but none of it is anything you should be afraid of. I'm not going to ask you any math questions. It's going to be super, super simple. So I want to start with something that I've been saying since I started this company in 2018 at South by, and that is that this, not artificial intelligence, is a space race of our generation. And it's very controversial, but the reason that I say that is because artificial intelligence is a goalpost we keep moving, right? Now we have super intelligence, which is what, when I was learning about AI, would have been normal artificial intelligence. And so, they're not competing technologies, but they're collaborative technologies. I don't think you can have true AI without the computational power of quantum computing. So I see it as a prerequisite, and therefore that's why I say I think it's a space race of this generation. I also look worldwide at China investing over $20 billion in the space, the US, Sweden, France, Germany, the EU, Japan, everywhere you can think of, investing so much money. It kind of looks like, a space program other countries can do because it's obtainable. Why did I jump on this company? Why did I start this so fast? Why have I been dedicating my life to it? Well, in 1927, Schrodinger and Einstein and a bunch of people got together at the Fifth Solenoid Conference, and quantum theory kind of came into being. And it took 55 years from that point until 1982, when Feynman and Benioff came up with the idea of using the spin of an electron or a particle as a way to do calculation, i.e. the birth of quantum computing as a concept. 18 years after that, right? So 63 years from our beginning in 1987, Los Alamos gets 7 qubits worth. 6 years later, 12 qubits at MIT. But the thing I want you to know is that, and I'm going to close this, sorry about that. Whoops. Let me see if I can, sorry, I was trying to see if you can see that screen thing. My computer froze. Sorry about that, guys. Trying to make sure that my face wasn't covering that important data up there on the top. So in 2017, when I looked at starting this company, and we started at the end of December of that year, we went from 17 qubits to 50. And in 2018, from 72 to 128, and 2019 to 160. So this space is accelerating incredibly fast, a lot faster than people think. You'll hear people say it's 40 years off or whatever. Well, here's the thing. IBM, which is one of 40 companies building hardware, just announced their roadmap. So to give you an idea of where they think it's going, they're at 27 qubits last year. They're at 65 this year. They're going to go to 127 next year, to 433 in 2022, and to 1,021 in 2023. Now, this is a big deal because I think the 1,211 qubit machine will get moved into 2022. And I'll tell you this, when you get that many qubits, if done right in the superconducting architecture they use, you can start solving some of the problem with having more qubits, with having more scalable architectures. And IBM has a goal, of course, of 1 million qubits. Now, when you think about this, what is a qubit? We can get to that in a minute and talk about all the different types, but keep that thought in your head and understand that 1 million qubit machine sounds exciting, but realistically, there wouldn't be anybody in the world who could program it because of its complexity. Again, quantum and AI, I think, have a marriage in the very near future. So look, this space is creating massive opportunities. Unlike every other market where people say there's a $40 billion market cap, $1 trillion market cap, We don't have that in quantum because we don't even really have a hello world. We're not in the days of AMD versus Intel in this space. We're in the days of little vacuum tubes versus mechanical gates, okay? And so because of that, the only thing people have been able to do is estimate the impact. And so we're in what we call the NISQ era. This basically means quantum computers that are noisy. Adding a qubit in a quantum computer isn't hard, but adding a qubit, not having the noise go so high in the system that you can't use it, is very hard. Noise is definitely a Achilles heel of this space right now. And so the thought is we're about 2 years into 5 years of that period, and that's only going to impact operating income by $2 to $5 billion across pharma, aerospace, finance, etc. And what is that business impact going to be? Material simulations, right? Now, broad quantum advantage, which is 10 years plus, is a $25 to $50 billion impact. And that's where you get near real-time risk assessment for financial firms, quants, hedge funds, et cetera. And that's where everybody's excited. Citi has a group, JP Morgan has a group, Goldman Sachs has a group. You probably can't find a hedge fund who isn't at least having a couple of interns look at quantum computing and start to try to build the algorithms out. Now, further in the future, 20 years out, well, then you've got your full-scale fault-tolerant machines. And that's going to be a $450 to $850 billion impact. Now, I'm going to tell you right now, I think this timeline is wrong. This is from Boston Consulting Group, incredibly smart. They've done, absolutely fantastic in their track record. But I think this NISQ era ends probably by 2022, and we get to a broad quantum advantage probably before 2025, sometime in between there. So again, I think this stuff is coming very quickly. But, what did we forget to talk about? What the heck is quantum computing again? Well, for that, let me start by using this coin. So think of it this way. This coin is a bit, a classical bit. And if we look at the heads, it's a 1, and the tails, it's a 0. Now, if I place that coin on a flat surface, and it can't go anywhere on that flat surface, and its heads up, it's a 1. If its tails up, it's a 0. But if I take that same coin and I flip it in the air, when it's at the apex of that spin, is it a 0? Is it a 1? Is it a 1? Is it a 0? It's in a superposition, a probability of either a 1 or a 0. And that's one of the 3 main things I want to make sure that we get as far as principles of quantum computing. Superposition is that Schrodinger's cat famous thought experiment. You put a cat in a box, you pump gas in the box. Is the cat dead or alive? Until you measure it, you don't actually know. And so superposition, think of it as this probability of getting a 1 or a 0. So I was flipping that coin, but is that what a qubit looks like? The answer is no. A qubit looks like a block sphere in physics. Think of it like a ball. Pointing straight up is a 1, pointing straight down is a 0, and we can manipulate it in 360 degrees for different probabilities of that. Now, entanglement, that is qubits being able to know the state of another qubit over long distances, what Einstein called spooky at a distance. And this means that there's a whole bunch of new things we can do with measurement, et cetera, et cetera. And then, of course, there's teleportation. Now, teleportation is something that affects a whole bunch of areas of quantum computing, but it also affects classical computing. So today, Apple Computer came out, showed their new laptops, and they said they're 5 nanometers. Why have we stopped at 5 to 7 nanometers? And one of the proposed reasons is that teleportation, if you get so small, past 2, 3 nanometers, you might not be able to block a particle and say it's a 0, or let it through and say it's a 1. So computing as we know it would potentially break down. And there's a lot of great articles online about that. Definitely suggest you read that, because that's another reason I think more and more money will come into quantum, and I think it will advance more and more. Now, these quantum computers we're talking about aren't going to replace the Apple laptops I just mentioned. They're not going to make the cat videos on the internet faster. We're talking exactly about what they're going to be good for and what they're not going to be good for a little bit later in the presentation. But let's talk about the science of that block sphere I just described. Essentially, we're talking about a 2-level quantum mechanical system that allows for a superposition. And again, measuring these superpositions give us probabilistic outcomes of would it be a 1 or would it be a 0. So what do? We have to have qubit operations. So now you take that qubit, and let's say we have a 4-qubit machine, okay? We can move things on any one of a number of levels. We can move them on the X, on the Y, on the Z, on the H, and you can see that there's these 4 states in each of those, underneath those letters, and you can see these block shares underneath what we're rotating and how we're rotating it. So you can see in this X, there's 1 rotation on X. You can see the rotation on Y, you can see the rotation on Z. And when you look at H, okay, you can see that we're rotating the X and the Y. And this is why quantum computing can be very intimidating to people, but it does not need to be, right? My mission is to make this evenly distributed, to make it democratized so that everybody can have access to this technology, because it's going to change the world in ways that we'll talk about at the very end. I'll give you kind of my vision, what I think the future is. Probably it's not right, but we'll see. It's what I believe. So let's talk about the power of algorithms. So great. So we have these quantum computers, and we have these different ways of doing algorithms. Now, what type of quantum computers are we talking about? Well, like I said, there's about 40 different hardware manufacturers, but there's really 4 ways I want you to think about quantum computers. Superconducting circuits. This is what IBM and Rigetti do. I want you to think about ion traps. Companies like Honeywell, IonQ, PsiQuantum are doing that. So superconducting, we're cooling those little atomic particles down almost to absolute zero, and they stop shaking around, and we can then manipulate them. Ion traps, we're trapping those particles in lasers. Then there's annealers. Annealers work similar in their function and their design and the look to a superconducting circuit, but they don't really do the same thing. It's just like annealing in metallurgy, right? So there's like a value and see where everything collects, and you can get some answers out of that. And then there's these hybrid things. So one of my favorite deal are quantum specific chips. So chips designed just for finance, just for chemistry, et cetera, et cetera. But if we have all of those, they're useless without an algorithm. And it's really the quantum algorithm that is so powerful. This is the first move away from von Neumann architectures and classical computing into taking quantum mechanics into the world of computation that we know. So for that, I've got a great example for you tonight, and that's going to be the classical drunk. So for those of you who don't know, let's say we just went to a UT game and we're going to go up to the bar and looking for our friends, and there's 5 people and only one of them is our friend, and they're all wearing the same jersey. So the way a classical walk works is we walk up, tap them on the shoulder, see if it's our friend, and then we flip a coin, and we go to the right, tap the next person, or go to the left and tap the next person. We continue to do that. Now, what this means in the classical drunk is that flipping a coin decides each step of whether we can go left or right. But as you can see in step 1, we go left or right. But in step 2, we could be further away. And in step 3, we could be even further away, right? Because the drunken walk is essentially a bell curve, right? So there's average 0, there's a standard deviation, we have a probability density, and we know that somewhere in there is where we're going to focus the majority of our search for this friend we're looking for at this game. So I would like to propose something slightly different, a quantum drunk. So if you use quantum superposition, then our drunk is able to go left and right at the exact same time, meaning that flipping a quantum coin to decide it allows us to explore both of those options. And what you're going to find is that gets related to it being infinitely better. If we had this entrance and we had everybody go in it, the pink being our quantum drunk, the green kind of teal being our classical drunk, you would see that most of our classical drunks would get stuck in that matrices, and only a fraction compared to the quantum drunks would be found. Why is this? Well, there's a lot of reasons. Think about how we might use quantum technology for search. If we were to search with a standard computer, we would look line by line by line by line. Same as flipping that coin and only going one of those 2 directions. But with a quantum computer, we only need the square root of the number of entries to get to the same result. And that's because we're talking about exploring a lot of space a lot faster. Think of it like a Plinko. We're dropping them in on the top. Where are they going? We're getting a more even standard distribution that looks like this. Classical random walk, bell curve. It's centered, it spreads slowly. We're missing all the information on either side. Quantum walk, more like vampire things, mostly on the sides, also covering the middle, much higher probability that we get to the answer we're looking for much, much faster. And that's because, like I said in that example of searching with classical versus quantum, in the classical, we can search n, and in the quantum, we can search n squared, a much larger set of data in a much fewer set of steps. And this is really one of the key things that becomes super important. And what does that mean? Like, where is quantum computing today? Well, when I started 3 years ago, there were about 100 people that mattered in quantum worldwide. And every quantum conference you go to, it's the same people over and over. I just stopped going after the third one. Today, there's probably 150, 200 people that matter. So this is a very, very nascent space. And the thing you have to understand is this is the equivalent of being right when Vint Cerf was working on the internet. This is the equivalent of being in the homebrew compute club. You coming tonight, you listening to this and trying to wrap your head around it and explore quantum computing, this is your opportunity to get in on the ground floor of what is the next computing revolution. Quantum computing will change computing more in the next 10 years than it has changed in the past 100 years. And that is absolutely demonstrable. So when will it get here? Well, pessimists say it's 20 years out. Optimists say it's 3. I'm a realist. I think you should be preparing today. I think you should be looking at how do you get skilled workers in your workforce, at how do you understand what it's going to take, at what's all the BS around buying the vendors, right? Early spaces have a lot of hand waving and magic in them. And hopefully in the Q&A, if you have questions about vendors or frameworks or software or whatever, I'm going to cover some of that, but hopefully to make all of that happen and really help you out. Now, when we think about where it's at today, we need to talk about the quantum trajectory. And many of you probably saw Google announce quantum supremacy. And some of you may have seen IBM respond with a white paper that said, that is a bunch of horseshit. This is a big, big issue. Everyone is racing, trying to find out how we're going to get a demonstrable proof point that shows that a quantum computer is better than a classical computer at something. So when we think about this trajectory, we need to understand what we're talking about when we mean faster. This isn't going to make cat videos on the internet faster, but there's a set of problems that are computationally complex that will take forever to solve. So example people use is traveling salesman. Probably not the best, right? Let's call it traveling salesperson. Let's update it a little bit and say it's an okay example. But if Jay and I wanted to go to 14 cities, and we put it into my laptop and we program up to optimize the route, that would take, 1,600 seconds or so. But if we move the number of cities up to 22, that same computer takes a couple thousand years. Move it up to 28, 30, it takes longer than the time of the known universe. And so when we talk about the problems we're solving, the way I think you should think about it is this. You have problems that have scale on their solution, where you add a few variables here, and the evaluation time skyrockets. So these are in chemistry, these are in mechanical engineering, they're in aerospace, material science, they're in financial. There are a bunch of problems that computers would take forever and ever. And frankly, I don't want to wait around to fix climate change or cure cancer or find new drugs. I would like to see this technology become relevant, but I can't do it without all of you joining. And this is very, very small community we're talking about. It's moving very, very quickly. There is going to be a huge draw to this, I promise you, in the next 24 months. So we look at that, we say, well, these are the kind of problems. So that's what it solves. How do we get to quantum supremacy? Look, it's a term nobody likes, everybody argues about. The real term is up there in the upper right-hand corner, quantum advantage. And that's where we over and over sustainably can prove that this is a better, faster solution for this certain set of problems. So why should it matter to you? Like, you came here, I hope you're interested in quantum computing. What's the big deal? Well, I think it's physics today, everywhere tomorrow. What I mean by that is in the early days of computing, classical computing, you had to be an electrical engineer to program a quantum computer because you had to understand the flow of electricity between the gates. Right now, you sort of have to be a physicist to do anything really awesome with the quantum computer because you have to understand the quantum mechanics of how that is working. What I hope and what I think is going to happen is that in the not too distant future, it won't just be for teleportation, for security or encryption. It won't just be things like Grover's search algorithm or Shor's algorithm for factoring and breaking encryption. It will be in search, privacy, security, everything you see along that right-hand side. I believe this with all my heart. Software development, big data, machine learning, all of it will be covered. And the reason is that the opportunity for all this in quantum isn't the problems that are being solved today, that they're looking at solving today, I should say, but rather the problems that we are going to run into after quantum becomes pervasive. There's going to be a whole new world. Now, how can I put that in a way everybody can take it home and understand? Let's time travel back to 1958. Grace Hopper has just invented something that will eventually become known as cobalt. A few years later, this guy Jack is going to come up with something called a microprocessor. That's kind of the point we're at today. So when I say quantum computing and I talk about all this fancy stuff, you might just be like, oh, okay, sounds great. Sounds like a science fiction and science, project. But think about back in the 60s, when that was created, nobody thought about the iPhone. Nobody thought about the internet. Nobody thought about an Amazon delivering packages in 2 hours. All of those things enabled by that. And quantum computing will do the same thing. It will be just like the internet. It will bring about another major leap in everything. Tons of companies are investing in it. More than this, hundreds of companies, banks, Google, Sony, Alibaba, doesn't matter. Doesn't matter if you're in energy, if you're in transportation, maybe you're in aerospace, maybe you're making phones or consulting like Deloitte, building military solutions like Northrop and Lockheed. Everyone is realizing, 3 years ago they didn't, but today everyone realizes the impact this technology is going to have, and nobody wants to be left behind. So what does that mean? Well, why is it useful? What's the impact? I said it's not going to make cat videos on the internet faster. Okay, it's not. Here's what it is going to do. Think about back in the early days of the US, when we had to travel. We arrived at Ellis Island, we got on a wagon, and we headed to San Francisco. And that journey took weeks, maybe sometimes months. Somebody died along the way, maybe you had to eat on. It was weird. But then the train came along. With the rail system, that whole trip took a week, right? So we have trains, we go a week. But no matter how far you go, eventually you reach an ocean. And that's where we needed air travel. That air travel didn't replace train travel in Europe or Japan or anywhere. It augmented it for a completely different purpose. We would never take a train to go to the Caribbean. We couldn't, but we would take a plane. And so think of quantum computers, think of classical computers rather, as kind of that train infrastructure, and think of quantum computers kind of as a plane infrastructure, all right? And that's where you can start seeing this crazy, ridiculous immense value. But what I want to focus my last, 15 minutes on, maybe 20, I might go a little over, is how can you use a quantum computer today? So let's say that we started this, I've told you enough that you're interested. I'm more than happy to answer questions until the cows come home. But how can you get involved? And this is where I'm going to do something that we've never done. And it's just special because I love Jay and I love Jessica. I'm going to actually give you some tools you can sign up and use tonight for free. And I'm going to give you a demonstration of how those tools work, a couple quick lessons, so you can actually go and play with this right now. So the first thing we're going to want to tell you about is a community at Stack Overflow called quantumcomputing.stackexchange.com. Now we help start it, we sponsor it, but it's completely open source, it's completely free, it's completely independent. It is a great place to get questions answered. Starting, we were told there wouldn't be more than 100 people involved, wouldn't get more than a couple hundred questions. There's now over 4,000 questions, 85% of them get answered in the first couple of weeks, and there's now over 10,500 people, physicists, data scientists, developers, quantum enthusiasts, really working on this. And so this is a great free knowledge for you to go and check out. And then there's a thing I'm about to give you about a little 5-10 minute demo on, and that is, how do you start in quantum? There's all of these different types of hardware. There's all these vendors. There's different software frameworks. There's 5, 6, 10, 20 open source software frameworks. How do you manage it? What about developers? What about this? We wanted to get rid of all of that, and we built a free tool that will remain completely free, that puts the power of quantum all in one place, accessible to everyone. And that's available at quantumcomputing.com. If you go to quantumcomputing.com, and I'll show you how to do this later, and you sign up, scroll all the way to the bottom, there's a thing that says request beta access. And if you do that, everybody for the next 2 hours, I will put into that software. Again, it's going to be free. It's going to release early in probably January, and but there's no reason you can't start using it tonight. Okay, so it's got a bunch of features. I'm going to show it to you. It doesn't matter. It's more powerful than software that costs a lot of money. But the idea here is it's not time to make money with quantum. It's time to build community with quantum. This is the early days of like the Apache web server, where nobody was using the internet. And NCSA was going to charge for it. And my friend Brian Behlendorf was a fledgling web administrator at a magazine that nobody knew about called Wired. And they hacked together the server and they built the Apache, web server, which trained the Apache Foundation, et cetera, trying to do the same thing with quantum. Lots of people working for free, giving resources onto this website that you can take and use in any way, shape, or form you want. So let's actually do something more fun, and let's actually take a look at some stuff. But before we go into that, just interject and see if I had any questions here that might Q&A. See if I go through a couple of these right quick. Oh my gosh, Brian's question. All right, these are really good questions. I'm gonna wait till the end of the demo and I'll go into them. But Brian, that's an excellent question. And everybody who asks a question, if you send me your address, I will give you a copy of my book, Quantum Computing for Babies, which I guarantee will explain quantum computing you can understand because it's real simple. It starts off with, this is a ball, it can be red or blue. And it ends with, now you know quantum computing. So it's pretty straightforward. But we'll come back to those questions. These are great. These are great. These are amazing. Sorry, the most questions I've ever got in a quantum presentation. This is fantastic. All right, so let me share my screen again. Let's give you some resources and tell you how to use them so that you can go tonight and start learning. So this is the Stack Overflow site I told you about. As we said, there's over 10,500 people in it, over 1,000 active every day. It's a really great resource. So when you're on Stack Overflow, you can obviously search for questions, right? Search for qubit or whatever the case may be, and you get all these different operations. There's also questions that are bounty. There's the active ones that haven't been answered or just getting answered, the hot ones, what the top ones of the week or the month are. But these are great, and don't let this scare you. You go to this is a great question. How do I identify this? You know, are you into math? Because if you're not, it doesn't matter. But look, the community has already answered it. And while that seems complex, you could learn a lot just reading, scrolling through there, asking questions. And don't forget that if you go to the hot questions, one of them somewhere for the longest time was, is quantum computing pie in the sky? So you can ask any question. Nobody's going to jump down your throat. Nobody's going to bother you. The community will definitely help you out. So quantumcomputing.com. First thing I want you to do is ignore the notified on launch because you are part of Awesome Forum. Jay and Jessica invited you. So if you scroll down to the bottom, it's a place where you learn, create, and share all your quantum goodness for free. You can request the beta access. It's a name, an email. Do you want to know if we send out some mails? And please agree to the privacy policy because we work globally, so we have to pay attention to GDRP and all of that stuff. But once you've done that, you'll be able to log in and you'll get this dashboard. So for the last 10 minutes or so of my presentation, probably a little longer, what I want to do is some actual quantum computing. And so, I'll show you a little bit of the interface. It's got different languages. You can search all of that Stack Overflow stuff from in here if you want. But it's got a couple things that are really useful to you to start tonight. Number one, we curate all the news from the community. And this is all curated. There are a ton of articles every day. We don't pick that many. Really great place for you to go, sign up, I'll approve you, and you can actually learn about this and what's going on in the industry, et cetera, right there. Want to get a little deeper, you click this tab here, bunch of free research papers on everything. Teleportation, unified classification frameworks, solving Danner's dilemma game, right? There's a ton, that's a lot more complex. So think of like beginner, really learning stuff, a little more advanced, probably goes over my head and yours pretty fast. There's also a library of quantum experiments. So you don't have to go learn how to write code. You don't have to do any of that. And you can create a project. And soon, and I'm not going to show it, but we'll have on our website, you'll be able to run sample projects from strangeworks.com for free, just messing around. But that's what we're trying to do. Simplify your access to it, simplify it, and it's free, and it's not going to be charged for. Eventually, enterprises will start spending money in 5 years, and we'll start figuring out how to make some. But this is very important. How do we do this? We're going to create a project. Now, we create a project called Austin Forum, and we can do a new project. This will be kind of your expert mode. So unless you're a developer, probably not for you. You can go and add files and start running all yet. So I'm going to delete that one. We're going to make a new project called Austin Forum again. And one of the other things we can do is, if you're a big fan of GitHub, you can pull that information in from any public GitHub repository and use it. It's super awesome. You can also browse that library, which is what I'd encourage all of you to do tonight. Find an example and run it. So let's say we're searching for a needle in a stack of needles. Grover Search is one of my favorite. This website has all of the algorithm, all the protocol on it, what the Hilbert space looks like, what the quantum circuit is made up, how we're initializing the qubits and the quantum circuits. And then it actually has all the code. Think of it like a mini quantum GitHub. So you can take any of this code, again, completely free, add the project. Grover Search is in the Austin Forum Q&A. Whoops. And a capital A. We can clone it. When you do, you drop right into, again, completely free development environment. You can start playing with this code. You can share it with your friends. You can share it with everybody in the world. Maybe you're playing around, you don't want to, you just want to invite somebody. You can just add their name right here, invite them to the project to share it with you. And here's the kicker. You can run any quantum experiment you want on a number of simulators that we host for free on quantumcomputing.com. So this one, if we look at the code, is using Qiskit, which is IBM's framework. And it's building a circuit that initializes 4 qubit registers and a classical bit register to read them out. And it's using Hadamard gates to create a superposition of all of the options. What does that look like if we run it? Well, we can, and whenever I use Zoom, it runs a little slow, so apologize. But you can also, of course, add any files you want. You can do, check out the code you ran, any console logging for errors, things like that. But in a moment here, I have no idea why it runs slow like this whenever I'm doing the Zoom, but only on Zoom, which is weird. We get back the results, and we see the framework, right, is Qiskit. So the framework, when you're using this, guys, that's what you're programming in. Rigetti's Forest, D-Wave's Leap or D-Wave's Ocean, BlueCat's, MDR's BlueCat, maybe it's Qiskit from IBM, maybe it's Circ from Google, maybe it's Q# from Microsoft. There's a ton of these things. So we pull them all together, make them really easy for you to use. Here's the circuit gate. So you can see we're doing a readout, and you can see that we take these states, we're manipulating them all the way down to where we're getting what we're looking for. Now, if we look at the circuit resources, it's 8 wide, it's 35D1 tensor factor. Here are the operations we did on it. Here's a histogram with the bits and the counts. We're looking for that needle and that stack of needles. Here's a table with all the output. Now that's cool, and that's easy, and I hope all of you go and can do it, okay? However, if we go back to our projects, there's something cooler. And that is that you can actually write in multiple frameworks and languages and send them to multiple or single quantum computers all in one sweep. So in this one, we took Rigetti's PyQuil. Again, everything we're showing you is free to access, all open source code. There is no excuse for you to not be getting into quantum computing today. But this is PyQuil. This is going to build a really simple circuit, as you'll see in a moment, compared to the one we just saw. And this was targeting the Aspen 14 qubit machine. But in the same code base, we've got Qiskit building the same circuit using IBM's technique. And then we've got Circ building the same circuit using their technique, Google's technique. And then we have BlueCat, right? Same thing. So we look at the results, we get the same thing. Framework is Forest, so they made the software framework we're using. Provider is Rigetti's Cloud in this case. The backend is Rigetti's 14 qubit machine. Here's our simple circuit, the super toy circuit, right? It's like one Hadamard, boom, we're done. Now, if we scroll down, we see the same thing for Qiskit on Rigetti on the 14 qubit, and the same thing for Circ on Rigetti on the 14 qubit, and then the same thing for BlueCat, meaning that one of the really cool things quantumcomputing.com will let you do is we actually allow for you to go one to many to many, many to one, and you can do all of this super, super easy. I mean, you've got a community of 10,500 people, you've got free software that we're not going to charge you for, and you've got something even better, which is a library of examples that you have documented, you can learn, read from them, play around. You're not going to mess anything up. Go in there, play around with it, tear everything up, go from there. Now, considering there are 37 questions, I kind of rushed some of that and left one of the examples out so that we can not throw us off too far and I can get to start answering these. And again, if you go to quantumcomputing.com and you sign up, I'll make sure that I'm kicking out your invite along the way. And I'll try to do that in real time while we're answering these questions. And geez, Louise.
Whurley, don't worry about the questions. Jessica will curate those. And
they're also good though. There's several I want. Can I have liberty to just barrel through them? Do you mind? They're really good.
If you want.
We've got 40 questions now. Do you realize that I've given 100 quantum talks this year and the max has been like 4 questions? This is absolutely fantastic.
But what you're saying is the Austin Forum audience is the best, smartest, most engaged audience you've been in all year. Is what I'm hearing.
100%. This is
perfect. It is recorded, so I'm just glad that we all have this confirmation. Thanks everybody for being here. We already knew that.
Yeah, you're welcome. Well, and I'm processing invite. I'm going to process invites while we're talking about all this stuff. So, Brian, I mentioned his earlier because it caught my eye because I opened the Q&A thing. Will quantum computing always require wire conductors? So this is amazing. So what Brian's talking about is if you've ever seen one of these machines, they're shaped kind of like a chandelier, and there's these cooling rings that go down where we're cooling it, and there's wires that go in the top that go to each one of those qubits, right? So yes, the answer is that is going to happen. How it is going to happen, it depends. I mean, you already have computers from PsiQuantum and from IonQ and from Honeywell that are ion traps. So there's no wires, they're just lasers trapping it, right? So you've got these kind of laser grids. So there's already examples of that, which is freaking fantastic. Then Aaron had asked about getting more in depth on how technology moves out of the research phase and into the money-making phase, which is also, Aaron, amazing question. If you are consulting, Aaron, you could get into that phase now, okay? No problem, 0 doubt. If you're a physicist. If you're not consulting, it's probably gonna be a little while before any of us make any money. Now, for me, this isn't a problem, and I'm happy to share my timeline with you, which is I started in quantum with the plan of coming in just early enough so that around 2022, it would hit. I'd have been in it for 4, 5, 6 years, depending on where you start the count from. And there would be the opportunity to actually sell some software and stuff. And that doesn't mean you won't see it sooner. That doesn't mean there aren't things. It just means we need to be, cognizant of how nascent this is. So let's see. This was another one I saw, which is not necessarily off topic. When will Whurley get into biological-based computers, DNA-based computers, other ways? I'm already there. The platform that we're building, the commercial platform, actually doesn't just do quantum. It does quantum or neuromorphic or morphic. We can add any resources. So, David, if you have a biological computer or a prototype or something you want to play around with and try to get on something, hit me up. It's whurley@strangeworks.com. I'd love to do that. And then you followed on, merging of biology and quantum, 100% that'll happen. You already have the merging of classical and quantum. You cannot use a quantum computer and would not want to use a quantum computer for, let's say Shor's algorithm, 5 steps. Step 1, is it an even or odd number? Step 2, is it a factor 2 coprimes? Step 3, let's pick a random number to perform operation in. Step 4, the nonlinear quantum deterministic magic. And then 5, did we get what we're looking for? Do it again. I could write you an iPhone app that would do steps 1, 2, 3, and 5 so fast. It would be a waste of time and resources to do elsewhere. So I think you're going to definitely see them happen. David, I'm going to answer your one more, but then I'm going to skip some of your others because you asked a lot of questions, but I would love to chat with you. How do you validate if they really work? We have a whole set of experiments. So we look for certain results. What we can't validate right now too well is it actually faster than a classical computer in the ways we imagine? Now, to help with that, what we've done is we've got the IEEE and ISO and all the standards group starting to form groups to do standards for performance benchmarking, and that will cover all of that. Christopher, what is the impact or reduction on energy consumption? Christopher, the cooling is intense, but it does far more computation for the energy that is being used. So it is a net gain if you think of it from an environmental standpoint. Now, sorry, my thing's moving around. Oh, would we be able to create 1 million qubits, and would we be able to get there right now? Yes, we could create 1 million qubits, but the system would be so noisy that we couldn't use it. Remember what I was saying earlier? Have 5 qubits, we add 6. It's easy to add a qubit. However, the noise in the system goes very up, and managing that noise is why we call it the NISQ era that we're in, which is this noisy intermediate quantum area. I'm going to pick out some fun. Somebody asked, okay, hang on, let's see. All right, David Lawson. How does the future workforce sub 5 years prepare for quantum economy? You go, David, you sign up on quantumcomputing.com. You ask a question, so you send me a mail and I'll send you the book. Again, everything we're talking about tonight is free and open. There are now classes at UT. There are classes at MIT. There are classes at Stanford on quantum computing. I don't think you have to be in a degree program to take those. So if you're a developer and you want some of those classes, probably go a long way. There's also a wonderful quantum computing meetup group here in Austin, if you're in Austin, as there are everywhere in the world. It's pretty easy. Go to meetup.com, look for quantum computing. It's probably something pretty close. I know of them in LA, Las Vegas, New York, Washington, Seattle, Singapore, Beijing, everywhere. There's plenty of them. The question I want to go to next is Miles' question. Which nations are the leaders in quantum computing? I think we need to be, and I think we're woefully behind. I think China is much further ahead than we're giving them credit for. I think we're probably in the second or third position. I'd say China, Japan, Germany, US, if I was to just kind of spitball it. As far as the US cities you're follow on that are doing quantum computing work, there's not really an apex. In Canada, you have Waterloo, and there's a whole density of quantum and universities and students and engineers. We don't really have that here, and that's what I'd like to see us build in Austin, and why I wanted to spread this message and evangelize quantum to all of you on the Austin Forum tonight. There will be government investment to create these quantum hubs. There were 2 grants given. Tennessee got one for Oak Ridge National Laboratories. I forgot where the other one went. Texas, Rice University in Texas, A&M, and UT all tried to get one, and we did not get one in Texas. But we'll see where those happen. For right now, I would tell you there's so few people in it, it's definitely going to be distributed, and you don't need to worry about whether you're in a certain city or not taking advantage of it. Sorry, as questions come in, I lose the ones I'm scrolling. Jay, are we doing okay?
Yes, we are. I'm removing questions once you've answered them. That's why
Okay,
there's this
great,
long jump.
great. I just want to make sure you just yell at me and tell me to shut up, because I've never seen this many questions. And Jay, if there's a way for you to capture these questions for me in Zoom, that would be amazing. This is absolutely.
I've never seen this many questions, and we have a curious, smart, passionate audience. This is probably a record for questions.
The best audience.
It is the best audience. I'm super excited. All right, so we're just gonna keep going. So what are the major pain points other than decoherence that need to be solved? There's decoherence, there's the noise thing we've talked about. More important than a major pain point, the major pain is we don't have our example of this is what you do and it's better and we've proven it, so that using your laptop is faster than using a pen and paper, and using a quantum computer is faster than using a laptop. We just don't have the example, unfortunately. James said, I've read that quantum computing will render the current cybersecurity systems useless, which is another one I glanced at earlier that I really liked. No. Yes and no. Think about it this way. If I had a quantum computer I need 4 or 5,000 qubits to break your public key, or to take your public key rather, and figure out your private key. But if I did that, and let's say it took me minutes, I'd have to do that every time I wanted to break a key. However, remember how security works. It's about time and resource. With enough time and enough resource, there's nothing you can build that I can't break. So saying quantum computing, you hear this fear and uncertainty, doubt, fear mongering around this, is going to wreck cybersecurity, is the equivalent of saying, going back to the World War and saying, the Enigma machine will allow for no one to ever be able to read any messages from Germany. That's not true, right? Because security, we build a wall, they break the wall. We build a wall. It's a constant dance of threat and remediation and threat and remediation. So yes, there will be people that will have access to quantum computers that will probably use them for not so great purposes, that will probably break some keys for somebody, or a bank account password or something. But I think by the time the power is there, there's already post-quantum cryptography available today that people have been doing. There's all kind of preparation around that. That's where the financial people have been also very focused. So I don't think you're going to have like a quantum apocalypse, like is often described. Justin, best question. How do semi-technical people really get involved short of getting a PhD in quantum mechanics? Go look at the frameworks, go to quantumcomputing.com, start studying. I believe we're going to see an acceleration in the abstraction layers, and the physics is going to become less important at a speed dramatically faster than we saw with classical computing. RD. Wow, when's my next book coming out? Wink. Thanks, RD. Smartass. I'm working on it. I promise it's going to come out soon. Matthew said that you don't think that true AI is possible without quantum computing. Can you elaborate on why? Do you think that the human brain takes advantage of quantum mechanics? I do, and I wrote a piece on this, Matthew, and was highly criticized by half of the neuroscience community and highly praised by the other half. And it led me into a million conversations on consciousness and other dimensions and everything that I was not prepared to have. The reason I think that they're in is that the problems we want AI to solve, to me, are these very large scale, very computationally complex problems. Meaning that if we have AI and it has the ability software-wise to do this, even with hardware acceleration, we could still run into that problem we run into with my laptop and the traveling salesperson example we talked about earlier. In other words, we may have the AI to do it, but we don't want to wait 4,000, 5,000 years for it to figure it out. Like, we need these two things to be married. And yes, I am on the side of the brain is quantum mechanical. I believe nature is quantum mechanical. And I believe that there is absolutely a way that eventually we will create a consciousness or a super intelligence using some combination of exotic computing, most likely quantum, and artificial intelligence. David Wright from London, dude, why are you awake listening to me? Explain quantum error correction and how far we've come so far. It's really key. So it is key. So as you know, in computing, we have errors, we have error correction. We figured out how to do that. Quantum error correction, I don't know that we're as far as we need to be on that. I'm a little bit of a naysayer on the approaches that exist now. Maybe that's because of my naivety in physics. But again, David, I see these things not as computers in their current state, but as really, really good equipment for exploring the quantum landscape. As a software engineer, I can't really use these things to do a whole lot other than learn about these things and try to advance the art at this specific moment in time. What with cloud computing with AWS or other cloud tools? They're fine. Those are great. AWS, Microsoft has a thing called Azure. It has 3 quantum computers available on it. I think you can use it free, but you have to apply and there's some loops. Amazon Bracket, you can go and sign up for now and probably get approved. They've got some Jupyter Notebook examples that are not bad. I think those are, Microsoft, Amazon are fine places to go. They're things that will very quickly get you into money. Whereas quantumcomputing.com is designed to kind of be this free for all. But it's very, very important that we have more of those. I would like to see IBM. IBM has the IBM Q experience. You can go play with it. Microsoft's is called Azure Quantum. AWS is bracket, and Google hasn't come out with one yet. I have a sneaky suspicion you're going to see one soon. Let's see. All right, Thomas, we kind of talked about the data encryption thing, so I'm going to skip that one. I'm still looking. David Ruth, how long will it take to compute the meaning of life? Forever. But I can just shortcut it and tell you it's 42. Becky Taylor, saw a project relating to optimizing toilet paper production. Feels delightfully agnostic. Okay, here I'll just what she is talking about, and I think I need to. Give me 1 second. If you log in to quantumcomputing.com tonight, and I've still got a bunch of you to approve, I apologize. You will see in the library the project Becky Taylor is asking about, which is called Roll with Demand, which is an example we did for the library based on a hypothetical problem of, for mysterious reasons, customers' demand for toilet paper exceeds the supply. And this is actually a really good one, I think, Becky, for everybody to learn from, because it has some really nice graphics, a little easier to understand, and talks about how we can go and figure all of this out. It's a great example. It's actually one of my favorites. We have some other what we think are clever examples coming out later too for the community. Now let's see. All right, we answered Becky's. Jay, if you're still going. Jay, are we officially in the 8:15 on time frame?
Yes, you are. And we need to, at 7:25, we need to, I'm sorry, 8:20, 7:25 where you are, right? We need to move to close the meeting kind of formally, and then we conduct extended Q&A. So we have a few slides at the end. So you've got about 7 minutes of rapid fire questions.
I'm gonna scan through and we'll try to see how many we can.
And then you'll have more questions. There will be more, so.
There will be more.
There will be more. There's more. There's 44 now. Geez, there's 64 questions, guys.
Well, what we'll do is, if some of these are still on that you haven't gotten to and they're still on the call, we'll give them a chance. We can pick them and we can promote them to panelists, and they can dialogue with you, which is always a really
anybody I see that asks more than one, I won't answer all of those, so they can do that maybe.
Absolutely.
So let's. Wow. Kunal, all the way at the bottom, Jay, can you please show some insight on the potential of quantum on optimization problems? Yeah, so a lot of people in Japan, they use a lot of annealing quantum computing. They use Ising models and do a lot of optimization. And they do this from everything for shipping to logistical routes to concerts to whatever. You can use it for anything that you need to optimize. Mostly though, you're going to see that used in logistics or in like warehouses. They give these pick to order, pick to light systems. And now what Fujitsu has done is actually created a quantum computing annealing model where you can find the most optimized routes based on what you need to pull out of the warehouse to make the workers more efficient. So you can do a ton of stuff with that. Gwen, easy one. Can quantum computing be used to create music? Yes, and it already has. And if you Google IBM quantum music, I think you'll find a YouTube video. I don't know how much you're gonna enjoy it, but that is. Ron, does quantum computing.com also support quantum annealer? Yes, it supports D-Wave, Leap, and Ocean, and soon will support Fujitsu and Hitachi's digital annealers as well. Oh, this is a great one. Dishan, great question. If there are multiple states, how do you know you've gotten the right direction? And the answer is you don't. What I always say, and physicists don't like this, but I always say the quantum computer is going to give you the answer that's most likely the right answer most of the time, but you're probably going to run that experiment again. Remember, we're working with a probabilistic system. So it's not necessarily like, yes, this is it. It's a probability that's there, and we still have to do that verification. Olaf, will quantum computing early focus be on low Brazilian? Will it take a long time to share problems in 64-bit? Not necessarily applicable. Everything you know about computing with quantum computing changes. You get away from von Neumann models, the whole 64-bit, that doesn't make any sense. Remember, if I have 4 qubits and I add a qubit, I have 5, or let's say 3 to make it easy. I have 3 bits, add a bit, I have 4 bits. you know how many outcomes I have. If I have 3 qubits and I add a qubit, I have n the number 2 to n to the number of qubits. So I get exponentially more powerful with each one of these. So all of those Moore's law, all this stuff like that, that's not going to apply to this, in my opinion. Clark, excellent question. What do you see being impacted most by QC? Not in order: finance, chemistry, aerospace, obviously pharmaceutical. When I say chemistry, I mean like all material science, things like that. Energy, 100%. Those industries all have massive investment in quantum computing already, or making them. Karthik, do you consider quantum computing to be a hardware problem or a software problem? Secret sauce providing a layer of abstraction for existing algorithms? That is an amazing question. It is both a hardware and software problem, and it is a chicken and egg problem, i.e. most of these computers being developed in a vacuum. There's not 30 million developers like there's in the Apple ecosystem when they go to develop a new product. There's not even 1 million. There's not even 1,000. And so, we have problems in the hardware and software. I think what you're going to see is that the problems in the hardware take a while to solve, 2 or 3 years. That moves fast. Software then takes off. Software's problem, as usual, as a software guy, is always the hardware. And the hardware guys always say, no, it's software. But the secret sauce you ask about, I don't think it's a secret sauce about providing layers of abstraction. It's very hard to provide layers of abstraction because we have no idea of usage or anything. I think the secret sauce, though, is understanding how things are going to work. Hardware will get commoditized over time. It is unavoidable. It's why Hyundai sells a $30,000 car that's the same as a $100,000 BMW. And software will continue to eat the world, and the value will be in the software. So I don't understand these companies that are getting hundreds of millions of dollars to build quantum hardware, because Amazon and AWS took companies whose machines were thousands and thousands of dollars an hour, and like Rigetti is 30 cents a task on Amazon AWS. So I think that's just my opinion. The hardware gets commoditized, the value being software. We need the hardware to be fixed as a prerequisite for some of the software things we want to do, but software is definitely going to move much faster. Roy, what is the danger of not being a world leader in quantum computing? Okay. So Roy, I don't know how you mean that question. Jay, can we leave that and invite Roy to join us when we do that 8:15 thing?
Absolutely.
Okay, because that could be, you talking about me as a world leader? Are you talking about the United States? Well, I want to hear you ask it. I want to have a discussion. I think that's a really, really important one, because not enough people understand the impact of this technology globally or how it could change global power structure.
We got time for one more quick one.
I was just gonna say, let me find one more quick one. Paul, will quantum follow this server client model? Probably not. Who knows? I actually envision a serverless quantum future. Jay, why don't you take over and then let me know when you want to go, and we'll pick these questions and get some more people, and we'll just keep going.
All right. Thank you very much, Hurley. That was the most questions I've ever seen asked and the most questions I've ever seen answered by about 10x. So we have a few more slides here for folks, and then we will move back into extended Q&A at a slower pace. So we hope you'll stick around for that. In the meantime, want to make sure you're aware of our upcoming events. We've got Tech for Social Good on December 1st. That's our holiday feel-good sort of warm, fuzzy event of the year, where we talk about how technology companies and organizations are contributing to make the world better and what they can do and what you as techie can do.
I expect everyone who's on this call to be there too, guys. If you're interested in quantum computing, I also want to know that you're interested in how we're using technology to make the world a better place. I expect to see all you guys. You will get emails from me because I'm leading that one.
For an extra bonus in December to end the year, we've got a really fun event on December 15th. You may have seen Patrick Curry present on the past and present of gaming technologies for us a few months ago. We are going to talk about the future of gaming technologies and their applications. And so that means not just entertainment, but workforce development, training, education, other applications of gaming technologies. And you're going to hear about some really cool technologies that are going to transform the gaming space beyond the home gaming consoles and PCs and standard displays you have now. So I hope you can join us on that one. And we will have multiple gaming tracks after that one as well. So whether you're a gamer or not, you can join in to one of many options that night, or you can watch one of them on Twitch that night. In January, we will do our now annual Tech Trends for 2021 and beyond, where Jay Williams of Quantum Materials Corp and I will highlight what the analysts, what the thought leaders, et cetera, what they are saying about the big tech trends for the coming year. And we'll share our thoughts and dive into a few that we'll cover in more detail later in the year. In February, we're going to cover tech and relationships and also tech and food. So those are our two events for February. We're still planning the March and beyond schedule, and you guys contributed some great ideas tonight in the chat. So we will make sure and schedule those for 2021.
Please continue the conversation. There's multiple ways. One of them is through joining our Austin Forum Slack workspace. Super easy. Go to austinforum.org/Slack, click join the Slack channel, enter your email address, check your email to confirm, enter your name, and click create account. Voila! It's magic, kind of, but not really. Please join, continue the conversation there, ask questions, be engaged. There's opportunities to moderate channels. There's an opportunities channel too if you are looking to collaborate, if you're looking for work, if you're looking to find people who will work with you. Come and join us. Come hang out.
I think we should create a quantum channel, since people have asked so many questions, and then we just have to convince Hurley to check in on it once in a while. How about that, Hurley?
Oh, Hurley in. Oh, you're on mute, Hurley. Hurley said yes.
Mute, but I think he was saying yes for sure.
I was saying, as she was saying that, I'm sending out invitations to 100 people that are there, and I have joined the Austin Forum. So let's create a quantum channel. We'll do it. That sounds good.
There we go.
Awesome.
I'm trying to get it
Done.
Again, I want to make sure and thank all of these annual partners. And you'll notice on this one, we have CVEX's logo in now that we've announced them. So thank you to all of our wonderful annual partners for making these kinds of events possible, for bearing with us during this pandemic, when we know a lot of companies' finances got tightened just a little bit. These companies have kept us going and kept this community growing. Thank you very much to all of you.
Thank you guys so much. Please help others. Help people get connected during COVID-19. The pandemic has really underscored that the digital divide is huge. It's huge in Austin. It's huge in Central Texas. Our partners at Austin Pathways at HACA are addressing it. Our partners at Austin Urban Technology Movement are doing work around it and bridging the digital divide. But if you have a device that you are not using, and we know everybody does, Austin Pathways have residents that need these devices to learn, work, and be well remotely. They'll have a way to pick them up safely, refurbish safely, deliver safely. All you need to do is call or email info@austinpathways.org. Please, please, please. It's really, really important right now.
That's awesome.
With that, we want to ask you all to help spread the word about the Austin Forum. We really are trying to go national now, except that we have zero marketing budget. So we depend on you. Please share our events on Twitter, on Facebook, join the Slack community, and convince other folks wherever they are to join the Slack community. We're starting to ramp up our use of LinkedIn as well. We think that will be a great way for all of you to build collaborations. And of course, by signing up on Eventbrite, you're likely to get notices about future events on Eventbrite. Please forward those to other people. We really do count on you to build this community and share more information with more people. Ultimately, we're about informing people so they're more aware of technology, they understand it better, and they become advocates for it, and they potentially become contributors to it. So it's really important for you to help us spread the word about it.
And as we ask at the end of this event, before we move into extended Q&A, one of my favorite questions of the night: what was the most useful or interesting thing that you learned or heard tonight? So put it in the chat. Please share what was something really interesting, something really useful that you learned from Hurley. I want to see all the answers in the chat. You guys had a lot of great ideas. So what's something? Share. Hurley, I know Hurley really wants to know and see those too. The answer is 42. Yes.
Yeah, right.
Everybody's excited about quantumcomputing.com. I was definitely one of the people who already signed up also.
I think everybody in a moment, you know what I'm learning is like our little beta approval system. I've found a way to make it more efficient, but I have almost everybody invited while we're in. So we only have 5 or 6 more. unless you
Perfect.
unless it's signing up to the top.
Future of quantum computing. Yeah, this was fascinating. So everybody, you have our blessing to, you have 2 minutes. I'm going to say 2 minutes because everybody runs late. Jay, you can't even walk. So at 7:35 on my clock, Central Time, Jay's somewhere else. Come back and we're going to do live Q&A. So Roy, you stick around because I heard him say, if you had a question in the Q&A that he did not answer, please stick around because you will have an opportunity to come on as a panelist and have some FaceTime with Hurley. So this is one of the funnest times of the evening.
There's a bunch. So we're
And
so
Scott Hendricks, please send us your email address. I love your comment and chat.
We're now at 70 questions.
yeah, so we really invite you. It's the bonus for like sticking around to the end is they get to hang out on camera. Although some people aren't ready for that, but it's still fun. I love it. So this is normally when Jay would go back to his liquor cabinet, and go get his whiskey. Jay, do you have whiskey at your?
I don't have any. No, I don't have any, but they did put some Mexican beers in the refrigerator here, so that's good.
Well, that's lovely.
Yeah.
That's great. And what else did people learn? The free beta system is useful. Learn that Austin Forum is seeking to go national. Oh, Scott Hendricks. Scott Hendricks, please email me, jessica@austinforum.org. Because if you're excited about Austin Forum going national, so are we. So if you can help out, Scott, please shoot me an email, jessica@austinforum. I'll put that to Jessica.
I really like George Bell's comment that Hurley is a computer nerd that still has personality and social skills. That was an interesting thing someone learned tonight, Hurley.
My wife may disagree with you, but I appreciate the compliment.
Well, you should copy and paste this and take it back to it.
Yeah.
You're like, look, somebody on the internet said something
That's
else.
a sure way for me to get in trouble. It's like when she asked me, has anybody ever tried to slide into your DMs? I'm like, what are DMs? Yes, exactly. Jessica knows.
I have no idea. No.
That was very convincing, Hurley. Good job.
Apparently, Hurley is very convincing.
Hang on.
I've seen a couple of questions, folks, about will the talk be made available afterwards? And the answer to that question is always yes. We record the events, we post them by the end of the week, as well as the slides from the event. So actually, we need to get the slides from you, Hurley.
No problem.
And we need to integrate them into the master deck too. So in PowerPoint format at some point.
Sorry.
But we'll post the PDF though.
Sorry, what?
I'll talk to you later.
They can exist in all forms at once until we look at them, and then we want to look at the PowerPoint form. That's the plan.
All right, I think it's time for extended Q&A, Jessica.
I think so. I'm gonna, our good old buddy Roy, let's see, are you there? Was the most recent person. So Roy, we're gonna bring you on. Roy was the one who asked the question about being a world leader. He will be joining us momentarily, I believe. If you want to quit the sharing, Jay. Quit the screen share.
Right.
Can you hear me?
There he is.
How can we capture the questions, Jay?
I have access to them with everything
Good.
afterwards. I can send it.
I'd love
you
to
if
get
you
all
want.
of them and just, yeah.
She's the Zoom Lord. She's got this.
All right.
Roy, are you there? There he is.
I am. So
There's Roy.
my question is, what is the danger in not being a world leader from the United States perspective?
Great question.
Quantum computing.
And that was what I thought you were asking. Although for a moment I was really flattered. You might worry like, what's the danger to me personally if I'm not a world leader in quantum computing?
Well, I'm worried about that too, but
you should be. The look, there's a lot of danger. We want to go to Mars. We want to fix planet. We want to return to kind of this is a new era of innovation for the US. And the danger is there's definitely danger on encryption stuff, but not in the way you think. So on the encryption stuff, I'm not worried about people breaking encryption. I'm worried about people having unbreakable encryption. What China proved a couple of years ago was that they could use quantum entanglement to send a very small amount of data. So nothing you should be worried about yet, but they did a proof from Earth to a satellite using those 2 entangled qubits. That's incredible. And
Well, that was another question I had. Is there any limit on the distance of entanglement?
so this is the thing. No, and it's supposed to be faster than light speed, but nothing's faster. I think there's a lot of questions around entanglement that still need to be answered. But I think that was like 1,700 kilometers or something that they did. But having a quantum internet, that's what we need to do. We were very, very prominent in bringing the internet around. There will be a quantum internet, and we definitely need to be a leader on that. Look, the danger is all the normal dangers of new technology that could be used for economic warfare, whatever. It's the same. But with this one, I think the danger level is much higher. I spoke to Senator Jackie Rosen and Senator Mark Warner, a bunch of people on the House and Senate arms and committees. And I'm looking forward to giving more testimony on the Hill about why we need to be investing in this. And what we need to be investing in as a country is education of middle school and high school students before they even get to college. This can't be like, I'm getting to college, what I'm gonna do. Like, we need to build it in early. So that's kind of my opinion on that. I hope that's helpful.
It is, and I think I agree with 100% on the education part, and I'm anxious to see how we can progress as a nation in quantum computing, and hopefully, if not be the world leader, certainly not be too far behind.
No worries, no worries. Thank you very much for the question. Anne asked a question that's actually kind of interesting. Might lead us to an example.
Let's see if Anne's still on. You said
A-N-N-E, Annie, sorry, it's the only thing, there's no last name.
let's see. I mean, you can always answer. We just love, I think.
Sure, I'll just answer that one, and I'll tell you, while I'm doing that.
Oh, here she, let's see. She's on, yep.
Hi.
Sorry, she'll come up, she'll pop up sometimes there. Anne, are you there? Okay. Are you there, Anne? Oop, is your.
Anne, you're on mute.
Sorry about that. Okay.
Please, Anne, what question would you like me to answer?
Well, I was wondering how this relates to library catalogs and online libraries.
Yeah.
I'm working with a group that has an online library catalog, and we're trying to make available electronic or digital books, not necessarily ebooks, from out of copyright materials. And a catalog is a messy system. Can this work better?
So it can work faster at searching those large amounts of data. Make no mistake,
Okay.
Google is a giant library, and they index a
Yeah.
bunch of stuff, and their interest in quantum computing is directly related to the ability to make their core business work faster.
Sorry, I don't know what
So-
to help with that. Here are other things you can try.
That's my Google device on my desktop that heard its name. They're also spying on all of this. But no, it would be useful in finding stuff in an index. So could you take the Dewey Decimal System and build a modified version that was, searchable by quantum computers? Actually, I'd love to think about that. I don't know, that certainly possible.
Well, our project doesn't use any particular cataloging system because it's kind of a wiki library. It's all sorts of libraries contributing, like like WorldCat or something.
Yeah, it probably wouldn't be that useful for that right now today.
Okay. Okay, thank you.
Sorry, I calling you up to ask a question and being like, no, that's.
No, well, I mean, I don't know enough about this to know how to ask a question, but it just seems
That's
like.
a perfectly fine question. I just have a disappointing answer for you.
Okay.
And then we talked to him earlier. I'm gonna pick the next one.
We can also ask for a new round of questions of people in chat. That's a way that we can.
There's still questions coming.
They're still coming in. Well, true, but yeah. Thank you so much, Anne, for joining us.
Thank you so much. We're gonna break. Okay. You can pick anybody, but Sajjad, is that right? Sajjad, am I saying that right?
Oh, yeah, I see Sajjad.
Mohsen. And then we're going to go to David Ruth next, and we'll let him ask any one of any of the.
Yes, it is right. Yeah.
Hi,
Sajjad.
thank you. So your question was, ask your question.
Yeah.
Sorry.
The point is that since I have studied in Japan and lived there for 7 years, so I was thinking who has the most quantum computers in terms of utilizing the power. And I know, since I have lived there and I know how they use things, so it's just a curiosity living here now in Austin. And are we making those computers, enough computers, quantum computers, or not?
Well, we certainly have a big computer manufacturer in Austin that should be thinking about building quantum computers. But so you also asked which countries have most. So Japan doesn't necessarily have the most. There's not a lot of these. IBM has their entire fleet is probably 7 to 9 machines. Rigetti has 2. Honeywell has 2. But not really, because it's a replacement of one. So whenever we do these computers, you have like Honeywell has their version 0 and they go to a new version. They're basically taking that same machine and updating its number of qubits and producing them. The fab needed to produce them, that is not where it needs to be. There's only a couple fabs people can really do it, and that's only for the superconducting circuits. That has nothing to do with the ion traps, the annealers, et cetera, et cetera. Japan certainly, though, has a much higher knowledge and acceptance and vision of quantum computing. I spent several weeks there in 2018 working with Professor Nishimori, who's the father of annealing, and a bunch of other famous quantum people. And, easiest conversations I've ever had. I mean, they know everything about it. They've been thinking about it forever. They have all the arguments around everything. But we need to be building them. And I'm actually trying to get time with the governor of the state of Texas to say, you lost on the quantum hub. Maybe that's not what you should be focused on right now. We have 3 very good universities, Rice, UT, and A&M, all working with quantum, and we could build our own hub. We don't need the government to do that. Like the state of Texas is very capable of doing that on its own. And then maybe that drives enough interest. There's a Dell quantum computer in the future. Who knows? Thank you very much for the question, Jessica. David Ruth has asked a ton of questions. We're gonna pull him next, ask one, and then after him, go to Mark Murdoch.
Perfect. So thank you. David's still on. I'm always excited when people stick around to hang out here. So David Ruth, we just brought you up to panelists. Come on down.
Hey, David. You ask a lot of questions, so you get to pick one in person, man. Which one would you like to ask?
So this is a new one. One of the challenges is logistics and the delivery of goods and making it very dynamic. You gave the example of the traveling salesperson. But in the future, as we have millions of things roaming the planet and we want to optimize, will these devices be able to be miniaturized and we'll be able to have them in our vehicles?
That's a great question, because I was going to say autonomous vehicles, number one place these things will really be effective for optimization, right? Because there's a ton of optimization problems there. When you think about that and you think about optimization as a problem, you don't have to have, there's real-time optimization and there's optimizing the route. So all the trucks are leaving FedEx in the morning. We've optimized all the routes. You don't need access. You don't need anything in the trucks. You don't need anything like that. The way people and services will access quantum computers, just like we do the internet. So you'll be searching on Google, not knowing you're using a quantum computer, or your map on your car will tell you where you're going or the best route to go, but you won't know that that was processed by a quantum computer. So think of these things kind of like HPC infrastructure. So they're in the background, they're doing a ton of stuff, they're affecting our lives every day, but we're not sitting down at the server bay messing with them. There are probably more optimization problems and effort than there are any other area. I think more than chemistry or finance or anything. And in Japan, they have a ton of these great examples. In fact, there was something on addressing the complexity of supply chain optimization challenges for modern businesses with quantum. They had an entire little conference on it. And last year I spoke at the Reversed Logistics association or some crazy group I'd never heard of about quantum computing. And they were looking for warehousing and other logistics. But you don't need that. They're not going to get small for a while. And you don't need to put them. I don't want to say never, because I don't want to be the IBM CEOs like personal computers. We don't need more than 3 computers, or nobody ever have one in their home. But I hope that they will get much smaller. They already are in some areas. The ion traps and other stuff, they're not miniaturized by any means, but they're not a whole room. But right now, if you look at one, you're looking at a box about 10 by 10. Mainly the problem with making them small, for what you were just asking, is the environmental shielding that's necessary. So when you see that giant quantum computing box, there's a tiny quantum, in fact, there's not even a tiny quantum computer. What you have is, you have these cryogenic rings, if you're thinking about superconducting, which are my, that's my favorite right now. And you have the chip down at the bottom. That's all. And that's probably about 2 foot at its biggest part, going down to basically a chip. Everything else around it is environmental shielding. Gamma rays affected, solar flares affected, the wind, the shaking, the vibration of the earth. Many of these things are mounted on systems to keep them perfectly from moving. Because remember, you're talking about taking atomic particles, cooling them down to almost absolute zero to put it in a state where you can use it. So you bump it, I walk up to the side of a machine and I hit it or something like that. You'd be surprised at the effects that you can have on all of that. I mean, I'm making a joke there, but they're very, very sensitive machines to environment. And that's where the size come in, is in the shielding, not necessarily the actual chip itself.
Thank you very much. And by the way, I talked to Tony from the Reverse Logistics Association last week.
Yeah, well, don't give me a bad rep there. I was like fascinated. The product displays they had there, I was like, what? Like it was pretty amazing. It was absolutely amazing. We're gonna go to Pete Harris next.
Okay, so Pete Harris is not here, and neither is Mark, but you're welcome. Thank you so much, David.
Thanks, David.
You're welcome. You are welcome to answer any questions you want to answer. But
well, he just said, what's the biggest challenge and obstacles that are preventing quantum computing from being used for real life applications? Look, we're just not there yet. I mean, we need hundreds, if not thousands, of qubits. We need noise and air correction to be in a much better state. Those are probably the biggest challenges, right? The noise and the air correction, the qubits, they take care of themselves. We know how to add qubits. We don't know how to add them and not have everything go to crap. So that's probably the biggest challenges. I'm going to answer another one right quick. Well, is AZ online? Because we can have them ask it. If not, I'll answer that one.
AZ, you said?
Yes, it just says AZ.
It doesn't look like it.
There's a question from Becky Taylor. She's got a couple, but one, it starts with some say the computing industry was largely supported by the Defense Department. Can we get her on to answer that?
Becky's here.
Becky's on?
Yeah.
Yep.
Yeah.
Found her.
If she can come on, that's a good question.
I did not accept questions from Becky Taylor. It's a general rule. Try to avoid it.
We actually require you answer questions.
We do, because she has spoken at the Austin Forum before. So
that's right.
Austin Forum speakers have to connect.
Shock. Yeah. I was actually texting with Becky earlier.
Hey guys, I don't know. I guess being promoted was a taxing thing for my laptop.
That's okay. How are you doing?
I'm thinking of your DoD question.
Yeah, a lot of people would say that the DoD had a large hand in helping in the 70s, and I just haven't read a whole lot that would say that the DoD has been investing as much.
Oh yeah, tons. I mean, Oak Ridge and Lawrence Livermore and Los Alamos have been working on quantum computing literally since they were brought online. So, I mean, remember, this goes all the way back to the quantum mechanics of 1927, and the quantum computing comes in around 82. So they have the DoD, DARPA, they all have very massive quantum programs.
So that's more to be attributed to, for a lot of good reasons, they're just not making it as easy to find that information as the commercial stuff.
I think so. So we helped pass a thing called the National Quantum Initiative, which was signed by the president 2 years ago, a year and a half ago, something like that. Anyway, that is hopefully the remedy to that, which is to build these quantum hubs around the US, have the research flow through them, have it shared with universities, have a lot of that more be open. And it's basically funding for those kind of activities. So that's, that's good.
So what I
right.
hear you saying, Hurley, is that you're confident that the mechanisms that are being chosen by the defense community to support quantum are as effective as what was done in the 50s and 60s to support the first phase.
And we know how that worked out.
Yeah.
But probably, hopefully not.
Okay.
And I know how you message back, and I will message you later, I promise.
Yes. Good to see you. It was really great.
Good to see you. So John,
I did want to confirm one thing. Is the platform when I signed up and hopefully I'll be approved.
you did. You should have.
So is the platform connecting with simulations of each of the platforms? You actually want to deal with the two machines that are out there.
So when you're using quantumcomputing.com, you are using primarily simulators because all of the hardware is very expensive. So like $1 million commitment, a $3 million commitment. You can do that in our enterprise. Now, there are two companies who I am trying to talk into giving free actual quantum computers to put onto quantumcomputing.com. I think it's a strategic advantage for them because then people get to use it for free and they get the name. I think there's a good deal. We'll see if that happens. That would occur in tandem with the launch officially in probably early in the year of quantumcomputing.com. So the answer is you're using simulators that we host that are set up as horizontally scaled microservices. And then you can also from there, if you have a key or something, you could run out to something else. But the majority of people aren't going to have any of that access.
Yeah, and for the first 6 months, everybody's just trying to figure out how to use the tools anyway. So yeah.
Precisely.
Thank you.
You're very welcome.
I'll recloak.
And I think we're going to go to John Lockman next, if that works. Is John on?
Let me check. He has to be. I will be very. Yes. John. I was like, he has no choice. He better know. He does. Okay. Johnny. Yes.
All right. Hey, how's it going?
Hey, it's going good. How are you, John?
Excellent. I really like the whole talk, and given that it's inevitable, what's your favorite thing that's going to be enabled by quantum, and what's after that?
So, sorry, I have to laugh. Every time somebody signs up, and we have people who have links that are signing up, and then we have all of you that apply for the beta, and I'm approving them. And so all I can read is the best Slack message ever. It says, everyone, stop. Chicken and the egg is just a beta request. Chicken with no egg is a straight up sign up. Because the whole team gets alerts. I forgot to tell them that I was doing this. So we just had all of these people, plus there's an event in California as well. So there's like 300 people signed up while we've all been talking. So everybody's like, what's going on? Is this an attack? Like, they're like, hey, on, why?
Are we getting attacked?
Yeah, it's a lot of people. It's a lot of people. So let me tell you my favorite. There's only one thing. Favorite thing and what's next. It's all one thing for me. I got in a lot of trouble at a conference earlier this year. No, it was late last year. I was in Oslo, Norway, and I was with a woman. We won't say who. She's an astronaut. I love her to death. She's amazing. But she was given the whole going to Mars saves humanity speech. And I think we should go to Mars. Not against that. But what I said at the time was, but if we took that 20, 30, 40 billion dollars that we invested and we tried to fix some of the shit we broke around here, that'd be pretty cool, right? Like, we don't want to be a virus and use up all resources here and move somewhere else. And it was a huge moment. Look, I have no power over the Mars mission. I'm not going to kill it. I'm just saying, I kind of like planet Earth. It's not bad.
It's not a terrible place to live.
Been here for 50 years, worked out so far. So I have a project that I'll be announcing that I won't say, but let's say if you looked at my Twitter profile, there's probably a hint, which will be environmentally related with quantum. And I think that's it. And the next thing after that project, which is software, will actually be some hardware that I would like to deploy globally. And when I say hardware, I'm talking about millions of quantum sensors. And so there's some really, so that's where I'm most excited. I'm super, super thrilled about that.
Oh, that's great.
No
Thank you.
problem. I hope that answers your question. I'm hoping that happens in the middle of next year. Although there's somebody who wants to do something in June or July that may take up all my time, so it may have to be later, but I'm hoping sometime in the first part of the year, I get that pushed out the door.
But it's quantum, so it could be next year or right now.
Or it could be already done, yet I haven't even started. Absolutely. Thank you very much, sir. All right, Jay, how are we doing on time? Jessica, what's our?
We are about 8, but we can answer some more questions. There are still 61 people online and an absurdly large number of questions in the queue. I can't even believe how many questions have been asked. So we're going to save some of these for Slack and have you answer them there on your own in Slack. Just as
I'm going to say that if you'll give me the questions,
we will.
I will answer them all in Slack, or most of them. I'll answer whatever you, but why don't you guys pick out anyone you think is interesting, since it's your show, because there's literally so many.
It looks like the people who just came in, Michael and Matthew are probably still on if we want to have them chat, or
Michael Shepard?
Yeah, I think he's.
Is that what you're talking about?
Yeah.
Line them up. That sounds good.
Okay. Michael Shepard's going to get to be the lucky, I think, potentially the last one of the evening. He will come on shortly.
No worries. You, by the way, are a Zoom master. It's very impressive.
Michael, how you doing?
Hey, can you hear me?
Hey, Michael.
Yes,
yeah.
Come back in. Yeah. So trying to remember what I asked. Oh, so as you watch the pendulum kind of swing, I was thinking back to the token ring days. Central server compute. Then you got the PCs at the edge and back to cloud. And now we're seeing with edge, as we're trying to move and speed up, intelligence at the edge, we got more of the neuromorphic chips coming out. I was just thinking about, as quantum comes, are we going to see that pendulum swing back again? So I just been thinking, I lead our AI research team at Dell, and we're always kind of looking at what's the next thing beyond where we're at today. And right now it's all about federated learning and kind of the aspects around neuromorphic that's coming. So,
and neuromorphic is something we already have integrated a couple of different things in, and that's definitely important. As far as the pendulum swinging back from this kind of like token ring to this edge stuff, I think things continue to get pushed out to the edge, although there's always going to be the people who want, like, for instance, if we're working with the DoD, Becky was talking about earlier, they're not going to use my awesome Google hosted cloud system, no matter what anybody tells me. So I don't think you're going to see that. I think we've made that move. I think quantum computing going out towards the edge, towards edge computing, possible. Everybody is a cloud-based system right now. Nobody is selling machines. They're all leasing them. So I don't see that going back to a delivering stuff. Yet at the same time, number one request we get from supercompute centers in Germany, Japan, and everywhere is just put everything on a box and give it to us. And then we'll figure it out. Who gets access, all the CISAs. So we run into that a lot. But overall as an industry, hopefully then it continues to go further and further out to the edge and get distributed more and more evenly.
Yeah, I was just thinking about, when you got 5G and other stuff accelerating if you can move the key elements back to the central compute infrastructure, you may be able to drive, stuff more from a central intelligence aspect rather than necessarily having to go to the edge. But anyways, that was just kind of where my thought was. Appreciate it. By the way, this is great. Great.
Like it. Yeah, and feel free. We are sitting at the Slack channel. I tried to make a quantum channel. I don't have permissions. But
really, I don't want to derail this from the Austin Forum purposes, but Michael is somebody that, as you and I have our daytime job conversations, Michael is somebody that will be brought into that at some point soon too. Y'all will get to know each other.
I like how Michael is like, what just happened? He's like,
oh, it's okay. It was going to happen anyway. You didn't step in it. You stepped in it long ago.
Yeah.
All right, thanks, Michael.